And the last main part of Chapter 9 is exponential growth and decay. But here, I'm just going to discuss exponential growth. And as you can see, growth is growing. And so I'm just going to basically outline how the formula for exponential growth is derived. And also give some applications of exponential growth and how it can be used to solve some problems. This is a differential equation. dy over dt equals k times y. And this differential equation follows this statement. A positive quantity y increases or decreases at a rate that at any time t is proportional to the amount present. And that statement may or may not make any sense, but I'm going to explain it. So here we have this very same equation in more user-friendly form, and I'm going to basically break this down into the exponential growth and decay formula. So let's start by getting the variables to one side. So basically dy and y on the same side and k and dt on the same side. So now we use our calculus, integrate both sides, and dy over y, integrate that and you get ln of y. And on this side you get kt plus c. Don't forget the plus c. And now we take both sides to the e power, or both sides to the e to the both sides. Sorry, I can't math. And then so now we have y equals e to the kt plus c. Now e to the kt plus c, let's do it on the side right here, e to the kt plus c is actually the same thing as e to the kt times e to the c. But since c is a constant, e is a number as well, this right here is just one big fat constant. So we can add this and we can make this just simply c. So now we have, let's go back to here. Now we have y equals c times e to the kt. And this right here is your exponential growth and decay formula. And so lastly, I just want to outline a few uses of the exponential growth and decay formula. First, it can be used to find how fast or slow a population is growing, how many members there are after a certain number of years. Number two, it can be used to find money in a bank account, like you have the interest rate, and you can find how much money you'll have after 50 years or something. Number three, half-life. Radioactive isotopes is important to find the half-life and to see how much of a substance will remain after its half-life is gone. Number four, the most important to me, food. You can find you can see how the food supply increases or decreases based on like the rate of consumption, for example. And lastly, the most obvious, you can just use it in your homework and to do some practice problems.